Hello, my dear students. Myself, Debi Prasad sir, welcomes you all to the mathematics class. Today, I will explain you all about the chapter number 2, that is Introduction to Rational Numbers. In this chapter, you will be able to recognize rational numbers, identify equivalent rational numbers, recognize negative and positive rational numbers, and to express a rational number in the standard form, analyze whether two rational numbers are equivalent or not, and finally to represent a given rational numbers on number line. Now, natural numbers and whole numbers. We have already learnt about natural numbers and whole numbers. The counting numbers like 1, 2, 3, 4, 5 and so on all are called natural numbers. The number 0 together with the natural numbers forms the whole numbers like 0, 1, 2, 3, 4, 5 and so on. You can see that the set of natural numbers, that is n represented by n, forms a part of the set of whole numbers represented by W. Now comes the integers. Negatives of natural numbers together with the whole numbers form the set of integers. For example, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, etc. The set of natural numbers and the set of whole numbers each form a part of the set of integers represented by the letter capital I. The relation between natural numbers whose numbers and integers is given as follows. The arrows towards the right indicate that there is no largest natural number or whole number, and the arrows extending on both sides shows that there is no largest or smallest integer. The rational number system. Any number that can be expressed as a ratio of two integers is called a rational number. For example, -3/7, 8/2, -11/4, -6/-1 and 0/-8 all are examples of rational numbers. Similarly, decimals that can be expressed in A by B form are rational numbers too. For example, 0.25 is equal to 1/4 and -1.333 equal to -4/3. Hence, 0.25 and -1.333 are rational numbers. Some decimal non-terminating, non-repeating cannot be written in A by B form. Such decimals are not rational numbers. They are known as irrational numbers. For example, the exact value of square root of 2 cannot be written in A by B form. It is an irrational number. And pi is another irrational number. Remember that 22/7 is only an approximate rational value of pi. The integer 5 can be written as 5/1. Integer -5 can be written as -5/1. Therefore, all integers can be written in the form A by B, where B is equal to 1. All integers are therefore rational numbers. Now you know that 0 is equal to 0/1, that's equal to 0/2, that's equal to 0/-1, that's equal to 0/-2. Therefore, 0 can be written in the form of A by B, where B can be any integer except 0. Therefore, 0 is a rational number. Note that 0 divided by any integer results in the rational number 0. Now we notice, therefore, that the rational number system includes the natural numbers, whole numbers, integers and decimals, except non-terminating and non-repeating decimal fractions. Now, equivalent rational numbers. Equivalent rational numbers are obtained by multiplying the numerator and the denominator by the same factor. Therefore, 1 by 2 and 3 by 6 are equivalent rational numbers. Negative and positive rational numbers. Just as we have negative and positive integers, we also have negative and positive rational numbers. Every rational number other than 0 is either positive or negative. To find whether a rational number is positive or negative, we express it in such a way that its denominator is positive. Then, if the numerator is positive, the rational number is positive, and if the numerator is negative, then it implies that the rational number is negative. Standard form of a rational number. If we divide the numerator and denominator of a fraction by common factor, the value of the fraction does not change. We can use this method to express a fraction in its lowest terms. For example, 4 divided by 8 can be converted into 1 divided by 2. Rational numbers can also be reduced to their lowest terms in this way. If a rational number is expressed in lowest terms and its denominator is positive, we say that the rational number is expressed in the standard form. Dear students, I hope you understood the contents of this video. Practice the exercise problems from your textbook. Thank you for watching this video.